Good day, students. You are welcome to sirMATHS. In this our mathematical journey in the world of numbers. I've come today to continue our discussion. Our discussion today will be the further application of laws of logarithm. Remember, previously we treated the laws of logarithm and some of the applications. We are going further in other aspects of applying these laws. And today our discussion is based on grade 12, equivalent to SS3. Grade 12, S3. And like we are saying, it's a further application of the laws of logarithm. Let us have these few examples and see the situation we apply any of the laws that will be relevant in our solving the problem. Here we are asked to express we're expressing the following. As logarithm of single number. Number 1, log 3 plus log 4. Number 2, 3 log 5. And number 3, log 15 minus log 3. Let's treat this before we go further. Now for number 1, where we have log 3 plus log 4. Recall that we stated when we were producing the laws of logarithm that where we have multiplication, we add the logs and vice versa. So here we now say that this is log 3 times 4, giving us log 12. It is now a single logarithm. Previously it was 2 logs. Number 2, 3 log 5 will now give us log 5 raised to power 3. And that will give us 5 raised to power 3 is 5 times 5, 25, and 25 times 5 is 125. It's now a single log. Number 3, where we have log 15 minus log 3 to be expressed as a single log. This is log 15 divided by 3, and that will give us log 5. We have expressed the given more than one logarithm as a single logarithm. This is where we apply. Here we apply that first law we stated, and here we apply the third law. This other one we applied the second law. We still have other examples. Number 4, still expressed as a single logarithm. Number 4, 1/2 log 25. Number 5, 2 minus 2 log 5. And number 6, we have 3/4 log 16. For number 4, 1/2 log 25. We express it as log 25 raised to power 1/2. Remember, indices told us that when the power is in a fraction, the denominator becomes the root, while the numerator becomes the power. So this will be log the square root of 25. The square root, because this is 2 and square root, and we don't need to write 2 for square root. And it should be raised to power 1, but it's not necessary because any number without power is automatically raised to power 1, except for the correction where we can say raised to power 1. And this will now give us log 5. The square root of 25 is now a single logarithm. For this very one, this is 2, and there's no log written against it. Now, if you have log x base 10, and yet it is 2, we are looking for that very x. So you know that x, if we write this in index form, this is x equal to 10 raised to power 2. And raised to power 2, 10 raised to power 2 is 100. And you know that in every log that the base is not given, it's automatically base 10. So the 2 we have here is log 100. It's log 100 because there is no log written, there is no base written against this very log. So it's automatically base 10. So we write it by saying that this is log 100 minus log 5 raised to power 2. And that is log 100 minus log 25. Why 25? 5 raised to power 2 is 5 times 5. So that is log 100 divided by 25. And that will give us log 4. Why 4? 100 divided by 25 will give us 4. Each of them is now a single logarithm. For the next one, number 6, (3/4 log 16). This is log 16 raised to power 3/4. This will be log the 4th root of 16 all raised to power 3. Remember, I repeat, that indices tells us that when the power is in the fraction, the denominator becomes the root, while the numerator becomes the power. So what is the 4th root of 16? The 4th root of 16 is 2, because 2 raised to power 4 will give us 16. Then here is raised to power 3. And 2 raised to power 3 will give us 8. So we have log 8 as a single logarithm of 3 over 4 log 16. I do hope we are all following. Let us look at evaluation, where we are given some logs and we are expected to find a value. Evaluation implies find a value. Evaluate. The following logs: 3 log 2 plus log 20 minus log 1.6. We're expected to find this value, the value of this. So 3 log 2 plus log 20 minus log 1.6. This will give us log 2 raised to power 3 plus log 20 minus log 1.6. That will be log 2 raised to power 3 is 8 times 20 divided by 1.6. Where we have addition, we multiply, or vice versa. Where we have subtraction, we divide. This will lead us to 160 over 1.6. To save your time, to make this a whole number, or rather to eliminate this decimal fraction, you multiply by 10, and what you do to the denominator, you do it to the numerator, giving us log, this is 16 now, this is 1600. That will be log 100. We have not evaluated. We can go further by saying log 100 is log 10 raised to power 2. And that will give us 2 log 10. Remember, the base is not given, and so it's automatically base 10. That will give us 2 times 1. The value of that is 2. Why is it 2 times 1? We have discussed that when the log is equal to the base, the result is 1. So log 10 base 10 is 1. So that's why we have 2 times 1. And 2 times 1 is 1. That is the value of these 3 log 2 plus log 20 minus log 1.6. There are other areas we will look at where we expected to simplify. In the simplification, we can reduce the value of what we are given, or it will give us a distinct value. For example, we expected to simplify the following. Number 1, we have log 4 over log 2. Number 2, log 16 over log 8. Number 3, log 243 over log 3. Okay, let us treat the 3. This will give us, that is log 4 over log 2 will be log 2 raised to power 2 over log 2. And that will give us 2 log 2 over log 2. Log 2 cancel log 2. Our result is 2. That is for number 1. We have simplified. and the result is 2. Log 16 over log 8. This is log 2 raised to power 4 over log 2 raised to power 3. 2 raised to power 4 will give us 16. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Whereas that of 8 is 2 raised to power 3. So we now have 4 log 2 over 3 log 2. Our result is 4 over 3, which we can now write in mixed fraction. We have here improper fraction. One whole number, 1 over 3. So that is a value. We got a distinct value for that very one. And the next one is log 243 over log 3. So this will give us log 3 raised to power 5 over log 3. Remember that 3 raised to power 5 is 3 times 3, 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3 is 243. Resulting to 5 log 3 over log 3. Log 3 cancel log 3. The result is 5. We have found the value by simplification of the given logs. We still have some others we can look at. I want us to be versatile when it comes to any topic we have treated. The same simplifying the following: log 0.2 over log 25. Zero 0.2 is the same thing as 2 over 10, which is equal to 1 over 5, and that will result to 5 raised to power minus 1. So we have log 1 over 5 over log 25. That will give us log 5 raised to power minus 1 over log 5 raised to power 2. And we now have minus 1 log 5 over 2 log 5. Log 5 cancel log 5. Our result is minus 1 over 2. That is a simplification for this given logarithm. We have simplified. Also, let us treat this other one before we go to change of base. Here we expected to still simplify without using table. Simplify without using table. We have number 1, log 8 plus log 4. We have number 2, log 8 minus log 4. Okay, that is 3/2. This is log 8 times 4. That will give us log 32. We have simplified that. While this is log 8 over 4. That will give us log 2. We have simplified without using table. More examples. Under this simplification without using table, have log 8 divided by log 4. And then number 4, that is log 8 minus log 4 over log 4 minus log 2. This will give us number 3. We have been going with log 8, log 4 in each of them. So there, this will give us log 8 divided by log 4. I want you to watch the principles and how we treat each of them. This will now be log 2 raised to power 3 over log 2 raised to power 2. 2 raised to power 2 is 4, 2 raised to power 3 is 8. That results to 3 log 2 over 2 log 2. Log 2 cancel log 2. That will give us 3 over 2, which is one whole number 1 over 2. This number 4 is log 8 over 4 over log 4 over 2. This will give us log 2 because 8 divided by 4 is 2. And 4 divided by 2 will give us also 2. So this is 1, this is 1. And 1 over 1 is 1. These are the situations when we can give the both sides, either left and right, or the numerator and the denominator, the same base. In each of them, you see, you can get the same base. But there are situations where there is no power you will raise the base to give you the value of the next one. In that situation, we do what we call change of base. Change of base. Let us treat change of base. If you have log m base a, so, and it's not possible. In fact, in change of base, we now have log m. Can use a base log a base c. Now you have given both sides the same base. For example, we are asked to evaluate log 6.84 log 6.84, and that is to base 3. In this particular question, if you say let log 6.84 base 3 be x, just say equals to x. And normally, when converting this to index form, it becomes 3 raised to power x equals to 6.84. What I mean is that there is no power you will raise 3 to give you 6.84. No, there is none. So in that situation, we do what we call change of base. We now say that this becomes log 3 raised to power x equals to log 6.84. We introduce a non-base, let it be base 10. And that will give us x log 3 equals to log 6.84 all base 10 this time around. To single out this variable we are looking for, x, becomes x will now be equals to log 6.84 base 10 over log 3 base 10. We are changing base. At this point, you consult your 4-figure table. This is where table comes in. You consult your 4-figure table and ask yourself, what is the log of 6.84? The log of 6.84, if you check very well, you discover that that will give you 0.8351. And the log 3 will give you 0.4771. You can use my machine to divide it by this. That will give you 1.750. But if you use your log to go on, this becomes a number. You have number log. Okay, permit me to go up. I'm sure you have seen this. To conclude this, therefore, we now say with our log, number log. This becomes our number 0.8351. And this is, the other one is 0.4771. The integer here is about 1 point. You check for the log of this. This also about 1 point. You check for the log of this from your 4-figure table. From your 4-figure table. This will give you 92.9218. That is 83 under 5 difference 1. And 47 under 7 difference 1 will give you 6786. And remember, this is division, you subtract. And when you subtract, that will give you 8 minus 6 is 2. You carry one from here, 11 minus 8 will give you 3. This remains 1. 11 minus 7 will give you 4. And this is 8 minus 6 will give you 2. Bar 1 minus bar 1 is the same thing as minus 1 minus minus 1. This is minus 1. Negative and negative is positive. And 1 minus 1 is 0. You find the anti-log of 24 under 3 difference 2. 24 under 3 difference 2. This will give you, if you check properly, 1751. But this is 0. You know the normal thing. When we are coming from here to here, we add 1 to the integer. 0 plus 1 is 1. So you count 1 from your left. This is 1. I'm not talking of this one, I'm talking of 1 digit. So this is your answer. You can see there's a slight difference. With your calculator, it will give you 1.750, and this will give you 1.751, whichever. It is acceptable. This is what we can do when we have a situation that we cannot give both sides the same base. We now change the base. Remember, I've been asking you to subscribe to sirMATHS and just turn to the notification to keep you updated in our daily discussion on mathematics adventure. You simply click your subscribe and bell notification button. You will join us. For today, we are stopping here. You remember what we have discussed? Further application of laws of logarithm for our grade 12 students, equivalent to SS3. When next we meet, we'll go further. But before then, let me give you what you will handle for me. Log 6 base 2 under change of base. Then find a way of telling me what you get from this very question. Thank you once again for listening. God bless you. Till next week, we meet again.